this presentations we are going to discuss about contiguous memory. So the objective was to discuss various memory management techniques. So here, what is in contiguous allocations? The main memory must support both OS and the user process. So limited resource must allocate efficiently. So contiguous allocations is one early method. The main memory usually into two partitions. Resident operating systems usually held in low memory with interrupt vector. There is a process then held in high memory. So low memory and the high memory, the user process in the high memory, the interruptions or vectors available in the low memory. So each process contains a single contiguous sections of the memory. So the relocations registers used to protect user process from each other and from changing operating systems code and data. Base register contains values of smallest physical address. With the limited registers contains range of the logical address. Each logical address must be less than the limited register. The memory unit maps logical address dynamically. So can then allow the actions such as the kernel code being transient and kernel changing size. So actually the CPU generated logical address is checking the conditions with the register limitations. If it is satisfied, then the relocations value is added, then it will form a physical address that is to be referring in the memory. So the variable partitions. So here the multiple partitions allocations. So the degree of multi-programming limited by number of partitions. The variable partition size for efficiency. So hold the block of available memory. So holes of various size are scattered throughout memory. When a process arrives, it is allocated memory from a hole large enough to accommodate it. The process existing frees its partitions, adjustment free partitions combined. So the operating systems maintain information about allocated portions, free portions. So which are to be allocated, which spaces are free. So the allocated portions and thus then variable portions and the free spaces are the holes. So consider the memory has three process. So in this many process, okay, so in this the process 5, process 8, process 2 are available in the first slot. So second slot process 5 and process 2 only available. So in that time the process 8 to be in the whole. Afterwards, when upcoming the process 9, it is has burst time is small compared to the process 8, so it occupies a small space. So some spaces are available in the whole. So the dynamic storage allocations problems. So whatever any allocations available, it has some problems. So how to satisfy a request of the size n from a list of free holes. The first fit, best fit, worst fit. Three kinds of solutions are available. The first fit, it allocated the first hole that is big enough. Okay. The best fit allocate the smallest hole that is big enough. So much search entire list until ordered by the size. The worst fit allocate the largest hole. So must also search entire the list. So in each process search the entire list. Okay, but in the first fit, the first which one is better, so allocate that. The next one is fragmentations. The external fragmentations and internal fragmentations are available for the memory allocations. So here the external fragmentations, total memory space exists to satisfy a request, but it is not contiguous. Then the internal fragmentations allocated the memory may be slightly larger than requested memory. The size difference is memory internal to a partitions but not being used. First fit analysis release that give n blocks allocated 0.5 n blocks lost of fragmentations. To reduce the external fragmentations by competition. So shuffle memory contents to place all free memory together in one large block. Competitions is possible only if a location is a dynamic and is done at execution time. So IO problems latch job in memory while it is involving in IO. So DO IO here the input and output unit only into OS buffers. Now consider that bagging store has same fragmentations problem. The next approach is a Beijing. So physical address space of a process can be non-contiguous process is allocated physical memory whenever the latter is available. So available is not there. So in that time it can be used a paging whenever the later is available. So avoids external fragmentations, avoids problems of varying size of memory chunks. So divide the physical memory into two fixed blocks called the frames. The size is power of 2 between 512 bytes and 16 megabytes. So then divide the logical memory into blocks of the same size called pages. Keep track of all free frames. To run program of size n pages, need to find n free frames and load the program. So set up a page table to translate logical to physical address. So packing store likewise split into pages, still have internal fragmentations. Thank you.